Okay, number one, which expression is equal to y to the fourth times y to the fourth? Let's think about what this means. Y to the fourth means we're multiplying y by itself 4 times. So, y times y times y times y. And then we're saying we're going to multiply that by y to the fourth, which means the same thing. We're multiplying all of this, y times itself 4 times, and then we're going to multiply that by y times itself 4 times. Y times y times y times y. So how many times are we multiplying y by itself in total? We're multiplying y by itself 8 times. So y to the fourth times y to the fourth equals y to the eighth. Now, some of you may have said this. 2y, that's not a contrasting color. Let's use purple. 2y to the fourth. This is wrong, and let's go over why that is. The difference between multiplication and powers. If we have a value n and we add another value n, then we can say that we have n 2 times, or 2 times n, or 2n. However, if we take a value n and we multiply n by n, then we can say that we're multiplying n by itself 2 times. And we write that like this, n to the second power, or n squared. Remember, multiplication is just repeated addition, whereas exponents and powers is repeated multiplication. So, if we had y to the fourth plus y to the fourth, then we can say we have the value y to the fourth once, and then we have y to the fourth a second time, so we have y to the fourth 2 times, or 2y to the fourth. The 2 here means multiplication. We're multiplying the value y to the fourth 2 times. We have it 2 times. That's repeated addition. This is not addition. That's multiplication. Repeated multiplication is what we call exponents, or raising a value to a certain power. Number 2. What is the value of a cubed times b squared times 4a to the 6th power times b to the 9th power? The easiest way to think about this, or what you should realize, is that all of these terms are being multiplied. All of this is just one big multiplication problem, and multiplication is commutative. So I'm going to write this out the long way. A cubed times b squared times 4, and just because the 4 is next to the a doesn't mean anything. That's still multiplication. So 4 times a raised to the 6th power times b to the 9th power. Now, because multiplication is commutative, I can rearrange all of these terms and it'll still come out to the same thing. Remember, 2 times 3 is the same as 3 times 2. The order, when you're multiplying, does not matter. So, I'm going to change the order here, and I'm going to put my 4 first. And then I'm going to group my like terms together. A cubed times a to the 6th times b squared times b to the 9th. And now it's easy to see, okay, well, I can't do anything with 4, but I can say if I'm multiplying a by itself 3 times, and then I'm multiplying a by itself 6 times, then in total I'm multiplying a by itself 9 times, which is why we add exponents when we multiply like bases. And then all of that is multiplied by b multiplied by itself 2 times, and we're multiplying that by b multiplied by itself 9 times. So we're multiplying b by itself a total of 11 times. And so all of that can be written in shorthand, or without the multiplication signs, is just 4 times a to the 9th times b to the 11th. And there's our answer. And hopefully, if we've done this right, we're going to find this answer in our multiple choice. And there it is right there, 4a to the 9th, b to the 11th. So the answer there is B. And what is the value of ac squared d cubed times negative 6c cubed d to the 4th? When simplified, same type of problem. We're going to write it out the long way. 8 times c squared times d cubed times negative 6 times c cubed times d to the 4th. And we can just rearrange everything. 8 times negative 6 times c squared times c cubed times d to the cubed times d to the 4th. And the same reasoning applies. 8 times negative 6 is negative 48. Remember, positive times a negative is a negative. C squared times c cubed. What do we do when we're multiplying like bases? We add the exponents. So that's going to be c to the 5th. And that's going to be d cubed times d to the 4th is going to be d. We add 3 plus 4 is 7. And so we can write this. Negative 48 times c to the 5th times d to the 7th. And we've hopefully find that. And the answer is C. Negative 48, c to the 5th, d to the 7th. There we go. All right. Number 4. Which expression represents the simplest form of 24x cubed y squared times z over 15x squared times y? Okay. As we worked on this last week. All of this can be represented by splitting up this big fraction into the product of several different fractions. So we can say 24 over 15 times x cubed over x squared times y squared over y times z. And if we just have z on top, that just means what's on the bottom. We have a 1. And then we can simplify each one of these individually. 24 over 15 is just, let's see, we can divide by 3, so that's 8 over 5. We simplify that fraction. Now, if we have x cubed over x squared, remember what that means. Let's use n as our general variable. If we have an n times an n times an n, and we put that over an n times an n, well, we can think of this as n over n times n, times n over n, and times n over 1. And what happens when we have n over n? All right, that turns into a big 1, right? That's just 1. N over n, that's another big 1. So really, all of this simplifies to 1 times n. 1 times 1, 1 times 1, 1 times 1, and then we're left with just a single n. Which is why, if you recall, 2 of these n's up here in the x cubed pair with the 2 of the x's pair with the 2 x's down here, and we're left with the difference, which is why we subtract exponents when we're dividing them. So here we're left with x cubed minus x squared. So the 3 minus 2 is just x to the 1, which is just x. And because we're working with fractions, let's write x as a fraction. And here, if we've got y squared over y, well, one of the y's up here pairs with one of the y's down here, or the only y we have down here, and that makes 1, and so we're just left with y on top. 2 minus, and there's a hidden 1 there. 2 minus 1 is 1, and so we're left with y over 1. And we can't simplify z over 1, so we're left with z over 1. So we're left with the fraction, I'm running out of space here, 8 over 5. Well, let me simplify this. If we wanted to write one big fraction, what's 8 times x times y times z? That's just 8 times x times y times z. And what's 5 times 1 times 1 times 1? That just gives us 5. So we have 8xyz over 5. And, well, we don't have that in this form. We have it this way. So this is the same thing. This is 8 over 5 times xyz, which is the same thing as this. They kept the fraction here, 8 over 5 times xyz. And so the answer is D, 8 over 5 times xyz. Number 5. Which expression represents the simplest form of that whole mess? 63a squared bc over 9 times abc. Same thing. Let's split it up into separate fractions. 63 times a squared over a times b over b times c over c. Well, that just equals what? 63 over 9 is 7 over 1. 7 over 1. We divide both the numerator and the denominator by 7. A squared over a. The a down here pairs with one of the a's over here, and we're left with the difference, which is just a. A times, or a over 1. And then b over b is just, well, 1. And then c over c is just 1. So if we simplify this fraction, this is just 7 times a is 7a. And then we're just times 1 times 1, and that's 1 over 1, and that's 1 over 1, so we're just left with 1. That just leaves us with 7a. And there's our answer right there. And so our answer right here is A, 7a. Number 6. Which expression represents the simplest form of x to the 8th power raised to the 3rd power? Now remember what this means. When we're raising everything in the parentheses to the 3rd power, we're multiplying the value inside of the parentheses by itself. How many times? 3 times. So if you think about this the long way, and I encourage you to do this at the beginning so you understand why you're multiplying these instead of adding them, we can see that if we're taking x raised to the 8th power and we're multiplying x to the 8th by itself 3 times, it looks like this. And you know how to do this. When we are multiplying similar bases or identical bases, we add the exponents. What's 8 plus 8 plus 8? That's 24. That's x to the 24th. But when you raise a power to another power, instead of adding them, when you write it out the long way, it's easy to see that you are just multiplying this 8 3 times because you're multiplying x to the 8th 3 times. So 8 times 3 is 24, and that gets us the same answer, x to the 24th. And so our answer here is B, x to the 24th. Number 7, same thing. A to the 4th times b to the 5th, and we're taking this entire value and we're multiplying that 3 times. Now, it's important to realize that if we do this, we're taking a to the 4th. Oops, that didn't come out very nicely. There we go. A to the 4th times b to the 5th. And then we're multiplying this by a to the 4th times b to the 5th. And then we're doing that again, a to the 4th times b to the 5th. And because of the commutative property of multiplication, we can just say a to the 4th times a to the 4th times a to the 4th times b to the 5th times b to the 5th times b to the 5th. And same rules. A to the 4th times a to the 4th times a to the 4th is a to the 4 plus 4 plus 4, which is a to the 12th. And then b to the 5th times b to the 5th times b to the 5th is just b times 5 plus 5. I'm sorry, b to the 5 plus 5 plus 5, which is b to the 15th. And that's how to think about it the long way. A to the 12th, b to the 15th. However, when you raise multiple terms to the same power, when you raise everything in the parentheses, the power can be distributed to every term in the parentheses. So if you take the 3 and you distribute it here, a to the 4th times 3 is going to be a to the 12th. And then if you distribute it to this exponent, or this term. b to the 5th to the 3rd is just b to the 5 times 3, which is b to the 15th, and you get the same result. I'm not saying you have to do all this. If you don't understand why it works, yes, do all of this. But after a while, you should understand why you are distributing this the power outside of the parentheses. Number 8, which expression represents the simplest form of, you can't see that, 4x squared to the 0th power? Well, we know what the 0th power means, right? Remember, the 0th power, we get the 0th power when we have n squared over n squared, and that's what? 2, the difference between 2 and 2 is what? 0, right? So we get n to the 0th. But we know that n squared over n squared is really just 1. We only get an exponent to the 0th power when we have a situation like this, when we have the same value in the numerator as we do in the denominator. And that always equals 1. And similarly, we can write n squared over n squared as n squared over 1 times 1 over n squared. And we know that, how do you write n squared over 1? Just n squared. But how do you write an exponent in the denominator? Well, if your base is being raised to an exponent and it's in the denominator, we denote that by using negative exponents. So that would be n to the negative 2. And so this same situation, n squared over n squared, can be rewritten like this as a multiplication problem. And that can be rewritten as just n to the positive 2 times n to the negative 2. And when you multiply identical bases, you add the exponents. And what's 2 plus negative 2? That gives you n to the 0. And you get the same result. You just get 1. Oops. So, anything raised to the 0th power is 1. Our answer is D. Okay, number 9. What is the area of the rectangle? Now, we didn't explicitly go over this in class. For this, you have to apply what you know about exponents to create an expression for the area of this rectangle. Well, you know the area of a rectangle is just length times width. Always start out with your formula. Always start out with the big picture with an equation and then fill in your terms. If you don't think of it like this first, the problem is difficult. If you think of this first, the problem is simple. All right? Well, what's our length? Here, our length is 2ABC. So write that, 2ABC. That's simple enough. Our length is 2ABC. What's our width? Our width is 2 squared times b. Our width is 2 squared, not 2 squared, a squared. A squared times b. And what does all that equal? Well, we take the 2, we got it. We got an a times a squared. What's a times a squared? A cubed. What's b times b? B squared. And what's c times, we just have a c. So we're left with c. And there we go. The area of this square equals, this rectangle equals 2a cubed times b squared times c. Now, a trick that you can use on a test or even in real life to make sure that you've got the right answer. And this goes for any of these two. I should have been doing this for 1 through 8. But you can substitute a value for A, B, and C and get an actual number and figure out, or you can get an actual value. And then once you've come up with your simplified expression, you should plug in the same numbers and you should get the same value. The only thing that I caution is you shouldn't plug in 1 because that can be problematic at times. So a good rule of thumb is always use 2. So let's do that. What's 2 times, if A is 2, and B is 2, and C is 2, and that's just going to be 2 times 2 is 4, times 2 is 8, times 2 is 16. All right, so our length is 16. What is 2 squared times 2? That's just going to be 4 times 2, our width is 8. All right, so what's 16 times 8? 16 times 8 is, so the area of this square equals 16 times 8, and that comes out to 128. Whatever your units, let's say centimeters, remember it's squared. I didn't put units here, I should have. Okay, so if we've simplified this expression, if we've multiplied these terms correctly, then this, if we substitute 2 in for a, b, and c, we should get the same exact result. So let's do it. 2 times 2 to the third times 2 squared times 2 equals, and let's simplify this, 2 times 2 to the third is 8, 2 squared is 4, times 2, and that is 2 times 8 times 4 times 2. Oh, look at that, 128. Well, you could have also done, I actually should have done it this way. This is really just 2 to the 1 times 2 to the third times 2 squared times 2 to the 1. We have the same base. You're not always going to have this, but if you have, you've got the same base, so you can just add the exponents. That's 2 to the 4th, 6th, 7th, 2 to the 7th, and then that's going to be 128 also. So, we know that we're correct. The area equals 2a cubed b squared times c. All right, what is the perimeter of the rectangle? We've got to use the same rectangle. All right, well, you know that the perimeter is, we've got, well, let's think about the equation or the formula for the perimeter of a rectangle. Any rectangle is going to have a length and a width, and it's going to have the value of that width 2 times, and it's going to have the value of that length 2 times. So the perimeter of a rectangle is going to be whatever your length is times 2, or 2L, or 2 times the length, and whatever your width is 2 times, or 2W. Another way of thinking about this is where you're going to have L plus W plus W, and you know that repeated addition is just multiplication, and then we get the same result. L plus L is 2L, and then and plus W is 2W. And we can simplify this further by using the distributive property. If L is being multiplied by 2 and W is being multiplied by 2, then both L and W are being multiplied by 2, so we can write 2 times L plus W. And if you look what happens when we distribute the 2, 2L plus 2W, we get the same thing. Any way you want to think about it will achieve the same result. So, if we start with the big picture, all we have to do is substitute. So what's our length? 2ABC. What's our width? A squared times B. So, substitute. Perimeter equals 2 times, the length is 2ABC, 2ABC, plus the width is A squared times B. And then you just distribute the 2. What's 2 times 2ABC? That's 4ABC. Because you have 2ABC 2 times. You can think about, you have ABC 2 times, and then you've got all of that 2 more times. So you've got ABC a total of 4 times. And then you distribute the 2 to A squared times B. How many times do you have A squared times B? You've got it 2 times. 2 times A squared times B. And so your perimeter is 4ABC plus 2A squared times B. Now, I don't have enough space here, but if you do the same thing, if you plug in any number, I like to use 2, but if you plug in any number for A, B, and C, and you figure out what the perimeter is numerically instead of using variables, and you plug it in here, you should get the exact same result. If you don't, then you've done something wrong. It's a very effective way of checking whether or not you've done this correctly. All of you understand how to do this. Not all of you are going to get the right answer because you're going to make silly mistakes. Everyone makes silly mistakes. So double check your answers. And finally, oh, I forgot to put instructions here. what is the... Oh, no. Number 11. What is the circumference of the circle? Okay. Well, we're using the same idea. Start out with your formula. Circumference equals 2 pi r. If you start out with the big idea, everything is just a matter of substitution. It's easy. 2 pi r. Well, what's the radius? 3x squared times y. So 2 times pi times 3x squared times y. And this is just one big multiplication problem. Multiplication is commutative, so we can rewrite this as 2. I'm going to skip a step here. I hope you all know that this is 2 times pi times 3 times x squared times y. So I'm just going to rewrite this as 2 times 3 times pi times x squared times y. And that leaves us with 6 pi x squared y. And remember, what comes first? Your coefficient. What comes second? Your constants, or your transcendental numbers, and then your variables. Remember, is pi a variable? No. Pi is a number, just like 6. The only difference is we can't write pi down. So we use a symbol. The Greek letter pi. Alright, number 12. What is the area of the circle? Again, simple. If you start out with your formula. Area equals pi r squared. Well, what's r? The radius is 3x squared y. So just rewrite your formula, substituting 3x squared y. And then what are we doing to r? We're raising it by 2 to the power of 2. Now, what do you do to all of the terms inside of the parentheses when you raise the parentheses by a power of 2? All of this is being multiplied by itself one more or 2 times. So we distribute the 2. 3 raised to the second power, well, let's write the pi here, 3 times 3 raised to the second power is 9. X raised to the second power is x to the 2 times 2, which is x to the 4th. And then what is y raised to the second power? That's just y squared. What comes first when we have to simplify this? Our coefficient comes first, then our constants, then our variables. So our answer is 9 pi x to the 4th, y to the 2nd. And there's your answer right there. Again, can you substitute values for x and y? Absolutely. Do I encourage you to do that? Yes. Number 13, ha ha ha. Super duper challenge problem. Find the volume of the cylinder. Now, I called it a super duper challenge problem. I don't think it's difficult. You shouldn't think it's difficult, but it is applying something that we've been doing for 2 or 3 weeks now, and combining it with your knowledge of exponents. So, again, if you start out with the big picture, everything's easy. Volume equals base times height. What's the base in this figure? The base is a circle. So let's first figure out the base. The base here is going to be the area of a circle, which is just pi r squared. What's our r? Our radius is m squared times n cubed. All right, so I'm sorry, let's do this. Pi, and then r is m squared times n cubed, and we're raising that to the second power because we're squaring what r is. Well, this is simple. We got pi times, we distribute the 2. What's m to the m squared squared? That's just m to the 4th. And what's n cubed squared? That's n to the 6th. There you go. So our base, our area of the circle, is pi times m to the 4th, n to the 6th. So volume equals, we know what the base is now, pi m to the 4th, n to the 6th, times the height. Now what's the height? 4 times m times n. 4mn. This is just one big multiplication problem. Let's rewrite it so it makes sense to us. Let's take the 4 comes first, times pi, times m to the 4th, and we're going to pair that with a like term, or a like base, m, and then n to the 6th, times n, and all of this simplifies to 4 times pi, times what's m to the 4th times m. Remember, if we just have an m, there's a little 1 there. That's m to the 5th. And then n to the 6th times n, little 1 there, n to the 7th. Ta-da! And that's our volume. 4 pi m to the 5th n to the 7th.